Have you ever stopped to think about what time really means? We live by counting seconds, minutes, hours. But is time merely the ticking of a clock? What if everything we understand about it is wrong? This is not an ordinary question, and the answer might surprise you. After all, we're talking about something that shapes every moment of our lives and, at the same time, remains an almost indecipherable mystery. Time, this dimension that seems to flow in a single direction. Is it as constant as we think? Or could it stretch, shrink, and even mold itself according to the invisible forces of the universe? Imagine if time could be slowed down, or even reversed, simply by changing our position or speed. What would you do if you could control the passage of seconds? It sounds like science fiction, but modern physics suggests that time is far more flexible than we imagine. In this video, we will explore the depths of this topic, diving into complex yet revealing theories. We will discuss concepts that redefine time as we know it, questioning the very structure of the universe and prompting us to reflect on our place within it. Get ready for a journey that defies logic and promises answers that might change your perception of reality. But be careful, once you see time in this new light, you may never view it the same way again. Are you ready for this transformation? Then let's embark on this fascinating journey through time and the universe, where science, theory, and mystery converge. Imagine yourself in a dark place, a completely isolated environment, where the sunlight, the moon, and even the ticking of a clock are mere distant memories. In this absolute silence, a profound question arises. How do you know that time is passing? The concept of time, so familiar to us, seems to fade when we have no external reference. How do you measure the passage of hours? It's curious, but without the usual surroundings, our perception of time is as malleable as the universe itself, shaped by what we feel, not by what we see. When we lose external references, time begins to feel as strange as a distant star. Have you ever noticed how a night without electricity seems much longer than an ordinary night? The passage of time, in these moments, is something you feel in your skin, in the heartbeat, the breathing. It's as if the body itself tries to find a way to measure time, to follow an internal rhythm while the world around remains silent. This makes us wonder, is time something that exists out there, or is it something we create within our minds? This experience leads us to a deeper reflection. Does time really exist, or is it just a convention? Imagine a scenario where the only marker of time is the universe itself. In the absence of clocks, calendars, or any visible sign, time becomes almost an abstract theory. What we call time could actually be just a way to organize our perceptions. Perhaps this is the first step to understanding the more complex layers that make up the universe and how it interacts with our perception. But to do that, we need to understand how time was defined. The concept of measuring time is ancient, but the way we do it has evolved, adapting to the rhythm of the universe itself. Seconds, minutes, hours, and years are, in fact, the product of a cosmic dance. Think of the Earth's rotation, responsible for day and night, or the orbit of our planet around the Sun, which defines the year. Each of these units was born from the attempt to capture the pulse of the universe, something that happens with precision but is felt subjectively. It is impressive how something so vast and complex can be confined to numbers that fit into our clocks and calendars. These divisions of time are conventions, but they still reflect natural considerations. Months, for example, originate from the phases of the moon, while the week is a social structure we adopted, more cultural than scientific. Have you ever thought about how these cycles influence even our mood and energy? It's as if our own biology adjusts to the rhythm of the universe. Science observes, deciphers, and organizes these movements into units of time. But how each of us experiences time can vary greatly. On gray days, the hours can feel eternal. On lively days, time seems to fly. Even with all the precision of science, each culture still imprints its own way of perceiving time. The Gregorian calendar, widely used, is just one of many ways to measure time. There's also the lunar calendar, used in various traditions, offering a completely different perception of the passage of days. These variations show us that time is something that can be shaped by science, culture, and even personal perspective. But to truly understand time, we need something even more fundamental: defining the second, the smallest unit of this vast and complex specialization. When we think of a second, we often imagine something brief, almost invisible. But this seemingly simple unit hides a fascinating scientific investigation. The current definition of a second comes from something far beyond our senses. It is based on the oscillation of cesium-133 atoms. This atom vibrates at an exact frequency, a kind of natural pulse that allows us to measure time with impressive precision. Science has discovered, in the invisible atomic universe, the answer to measure something we feel but cannot see, transforming each oscillation into a reliable marker capable of keeping universal time synchronized. It's curious to think that, for something as common as a second, we rely on atoms vibrating at a constant rhythm. Without these tiny pulses from cesium-133, atomic clocks, which measure time with extreme accuracy, would not exist. These clocks, used in satellites and GPS systems, help keep the world synchronized, from traffic to global communications. It seems magical, but it's pure science. Each second, in essence, is the result of a complex calculation that translates the vibrations of an invisible particle in the universe. Scientists are already exploring other ways to measure time, such as oscillators based on different atoms, with the potential to be even more precise. Imagining the second as a human decision on how to interpret the universe invites us to question how we truly understand the passage of time. After all, this unit was shaped to help us grasp the flow of life. But is time truly fixed? Who knows? Perhaps it's more flexible than we imagine, as we'll see as we dive into the next layer of this journey. When we talk about time, the mind almost instinctively conjures the image of a clock. However, time is much more than the ticking hands. It was physicist Hermann Minkowski who first proposed a revolutionary view. Time and space are inseparable, forming something we call space-time. This means that time is not an isolated line we follow, but rather a dimension intertwined with everything that exists in the universe. This concept helps us understand that time is present in every corner of the universe, shaping and being shaped. Albert Einstein expanded on this idea in his theory of relativity, showing that time is not fixed and uniform for everyone. Instead, it varies depending on speed and the presence of gravitational fields. Imagine traveling close to the speed of light. Time, for you, would pass differently than for someone standing still. This notion completely changes the idea that time is the same for everyone and makes us realize it can be as mutable as the space around us. The universe is a constant dance between the dimensions we inhabit, and time is one of the protagonists of this grand spectacle. This vision of time as a dimension of the universe transforms our perception of it. It's not just something that passes, but a structure that connects us to the cosmos in a profound way. Just as we move through space, time also moves us in a constant and inescapable direction. From this understanding, we begin to explore another concept that challenges this imaginary line even further: the relativity of time, a theory that not only redefines this dimension, but reveals how intricately it adjusts to the rhythm of the universe. And this is the next step in our journey. Einstein's theory of relativity was a true game-changer for our understanding of time. It revealed that time is not fixed, but rather an experience shaped by the space we inhabit. The speed at which we move and the gravity of the environment around us directly influence our perception of time. Imagine being near a black hole, where gravity is so intense that time literally slows down. It's as if the universe has the power to manipulate time, making it as flexible as the galaxies that compose it. This flexibility creates an effect called time dilation, where time can pass differently for people in different places or moving at different speeds. A classic example? Astronauts traveling at extremely high speeds experience time differently than we do here on Earth. For them, time passes more slowly, and when they return, they may have aged less compared to those who stayed behind. This effect, while subtle in daily life, becomes significant on cosmic scales, and is one of the most intriguing proofs that time, far from being absolute, can be shaped by the universe itself. The notion that time can be stretched or compressed, depending on surrounding conditions, opens up a fascinating perspective. Time, after all, can be molded by cosmic situations. This malleability makes us question how we truly perceive the passage of time and how it differs for each of us. Understanding this relativity is like opening a door to a universe where nothing is as simple as it seems. And as we enter this new vision, we encounter an even more curious and profound idea about time: the arrow of time, tied to the enigma of entropy, which seems to direct the universe's flow toward the future. The arrow of time is a curious concept that points to the direction in which time moves, always from the past toward the future. But what makes time follow this specific direction? One of the most intriguing answers comes from entropy, a principle of physics describing the increase of disorder in the universe. According to the second law of thermodynamics, entropy tends to increase, meaning chaos always accumulates. It's like a glass that breaks. It can go from a state of order to disorder, but never the other way around, and this defines the direction of time. This idea of entropy shapes the universe we live in. Everything around us, from the stars being born to planetary systems dissipating, follows this same logic of increasing disorder. Imagine that. If we could reverse entropy, we could reverse time itself, reorganizing events to flow backward. However, in our universe, the increase of entropy is significant, and with it, the passage of time. The arrow of time is closely tied to the fate of the cosmos, with all galaxies, stars, and even ourselves following this same journey into the future. Understanding the arrow of time and its connection to entropy is a way of realizing that time is not just an individual experience, but an essential part of the universe's evolution. Ultimately, everything is carried by the current of time toward a state of greater disorder, and this destiny leads us to a profound question about the essence of time and the universe. After all, if time is driven by entropy, what does this reveal about the very purpose of existence? Perhaps, by better understanding this relationship, we can uncover clues that lead us to even broader theories about what it means to exist. So, after all of this, the question remains, what will you do with this new understanding of time? Now that you know it is not as fixed as it seemed, will your priorities change? Will you value each second more, or even question how you live? Time is an unstoppable force, but understanding its nature can help us use it more consciously, balance our decisions, and perhaps even shape a different future. And you? Will you continue being carried by the current of time, or will you take the reins of your own journey? Think about it. This is your chance to explore the universe around you with a new perspective, to see beyond what clocks and calendars tell you. After all, if time is relative, what are we waiting for to do what really matters? Sometimes, it's this reflection that leads us to realize how our choices, our presence, and even our relationships can be transformed with a broader and more conscious view of time. If you want to continue this journey of knowledge, subscribe to the channel and turn on notifications. Each video is a new opportunity to expand your perspective on the universe, on science, and on yourself. Don't let time slip away. Follow along to learn more and, perhaps, discover what else the universe has to offer. Because in the end, understanding time is understanding the deepest aspects of our existence.